So in a given problem is asking the value of current I in this circuit. If you see here, this is a voltage source, this is a current source, and if you see here, this is a 0 volts because this is a ground point, so that means this is also at 0 volts. So when it is 0 volts, the voltage between these two is nothing but this value. So before I'll go to apply KCL and KVL, first I'll try to convert all of them in terms of phasors. So if you see here, this I can represent in phasor notation with its RMS value, that is 2 by root 2 at an angle of 0 degrees. So that means this is equal to root 2 at an angle of 0 degrees. So the voltage here also root 2 at an angle of 0 degrees. And similarly I will try to convert this also in terms of phasor notation. So this is equal to its RMS value 2 by root 2. Since it is a cos, it is at an angle of 90 degrees. So this is root 2 at an angle of 90 degrees. This is in amperes and this is in volts. This is in volts. Similarly, I will calculate the impedance of inductance and the capacitance. So if we calculate the impedance of this, so we know that how to calculate the impedance. This is nothing but J into XL or J into omega T. So J, omega is nothing but the frequency. This is the 10 power 5. Sorry, this is not T, J omega L. So this is 10 power 5 and L is 2 microhenry. So this is 2 into 10 power minus 1. So this is J.2. So this is nothing but J 0.2 ohms. Similarly, if calculate for this, you will get this as minus J 0.25. Sorry, this will calculate. So for the capacitor, 1 by J omega C. So 1 by J into 10 power 5 into 4 into 10 power minus 6. So this is 1 by J into 0.4. So this is minus J 2.5. So this is minus J 2.5 ohms. So once you calculate all the impedance and all, now you can apply KCL and KVL so that you can find out I value. So if you see here, the voltage from this point to this point is nothing but root 2 at an angle of 0. So the current is like this. So that is also equal to this root 2 at an angle of 0, this point, minus 0 by the resistance, that is 1. So that means the current which is flowing here is root 2 at an angle of 0 degrees. And what about the current here? The current which is flowing in this direction. So if I take this as some I1 plus this current is equal to I. So I1 is nothing but I minus this value. So the current which is flowing in this direction is I minus root 2 at an angle of 0 degrees. So once you calculate this, you have to calculate the current in this path. So this current is nothing but this current minus this current. So I will take this as, I will give a name to this I1, I will calculate here. So I1 is nothing but root 2 at an angle of 90 minus of I minus root 2 at an angle of 0 degrees. So this is equal to root 2 at an angle of 90 minus I plus root 2 at an angle of 0 degrees. So this is the current here. What about the current here into the source? So this current is nothing but this I1 minus root 2 at an angle of 0. So I will give a name to this as I2. Nothing to do with that. I just calculate I2 is nothing but I1 minus root 2 at an angle of 0. So this minus root at an angle of 0 means this will be cancelled. So its value is root 2 at an angle of 90 minus I. Now if you see here, I have represented the direction is like this, so the drop will be like this, and also here I have represented this like this, so the drop will be plus and minus, and here since the current is flowing like this, the drop will be like this. This is very important to denote plus and minus. Once you denote this, you can write KVL. So if I write KVL here, so this is a plus voltage and this is minus voltage and this is a plus voltage. So if I write here, the voltage across the inductor, which is a positive, so that is J 0.2 into the current I1 already known, minus, because this is minus, J 2.5 into the current is I minus root 2 at an angle of 0. Next, the voltage across the resistor is positive. So this is, because I am moving in this direction, this is positive, this is negative, and this is positive. So this is plus, the voltage at here is root 2 at an angle of 0 degrees. This is equal to 0. So this I1 is nothing but it is in terms of I only. So the only unknown is I in this expression. So if you simplify this, you will get a value of current I, which is approximately equal to 1.5 amperes. So from the given options, the answer is option C.